Hello everyone. Let us start with a new session today. In today's session, we are going to look at the problem which is a typical bioprocess engineering problem. Have you ever wondered how much sugar it takes to grow a massive batch of yeast? Today, we are solving a classic bioprocess engineering problem which is involved with the yeast cell. This is a typical yeast cell that has the cytoplasm and it is having vacuum, and these tiny elements are mitochondria. Mitochondria is the powerhouse of the cell. Mitochondria. And this green one is the nucleus. This outer layer is the cell membrane. Cell membrane. Okay. There is a big fermenter which is having a capacity of 150 liter capacity fermenter, and these are the yeast cells. These yeast cells are really hungry and we need to hit a target of 50 grams per liter. So we need to find out how much glucose is needed. This is a simple question. So let us start with first let us look at our target. We are not just growing a little jar of yeast cells. We are growing a mountain of it, which is 1 lakh liter capacity fermenter. Okay. So to find out the total mass, we need to find out the total mass. In order to find out total mass, we need to simply multiply the volume with the concentration. I told it was 1 lakh. So 5 zeros, 1, 2, 3, 4, 5. Okay. Lakh into 50 grams per liter. Make sure you write the units because units are very important. That will give us a 5 million grams, or we can call it as 5000 kgs of yeast. Okay. 5000 kg of yeast. I've just converted grams to kilograms. That's about the weight of an adult elephant. Okay. So let us move on to the second step, which is step 2, which is about the chemistry. The recipe. Now look at the chemical equation provided. This is the whole recipe that is used for the fermentation process. It tells us that for every 1 mole of glucose we put in, let us look into the stoichiometric equation. They are telling us every 1 mole of glucose, this is a glucose, for every 1 mole of glucose we are putting in, we get 0.48 moles of yeast out. This is the yeast. Okay. But we can't buy moles at the store. Okay, you can't go at the store and say give me so many moles of yeast. You got to buy it in grams or kilograms. So let's find out the molecular weights. So let me write it here. For the glucose, which is C6H12O6, so what is the grams per mole? It is 180 grams per mole. Next we have yeast. Yeast is this C6H, not 12, this is H10. Then O is 3 and N is nothing, which means it is 1. So this is about 130 grams per mole. Keep those numbers in your pocket. We are going to need them in a second. Next, let us go and calculate what? The yield factor. What is X bar is? X is the biomass and S is the substrate. Okay. Here's a pro tip for these exams. Find out the yield coefficient. This tells us how many grams of yeast we get per gram of glucose. We use the formula y of x bar s is equal to, let me write it as moles of yeast into the molecular weight of yeast. Okay, that is divided by moles of glucose, because glucose is the substrate, into same the molecular weight of glucose. Okay, let us plug our numbers in. So that is nothing but 0.48 into what is the molecular weight of yeast, we just found it out, which is 130, and then moles of glucose is given as 1 into what is the molecular weight, we have got it as 180. So this will come up to 0.347. Okay, this means every gram of glucose will give us about 0.347, or let us call it as 0.35, okay, grams of yeast. Not super efficient, right? A lot of it goes into the carbon dioxide and water. To find out the total glucose, we take our total yeast goal and divide it by that yield factor. So we have 5000 kg. What is 5000 kg? This is the yeast. Okay, and now we are going to divide it by the yield. What yield we have got? 0.35 is the yield, or take it as 0.347, it doesn't matter. And the answer we are going to get it here as 14,409 kilograms. Let us round it off to maybe 14.4. What 14.4? Tons of glucose. Tons of glucose. What's happening here is we want to grow. To grow these 5000 kg of yeast cells, we are needing 14,000 kg of glucose or sugar. Okay, to grow 5000 kg of yeast, we will need 14,000 kg of sugar, or 14.4 tons of sugar or glucose. It is one and the same. So this is how you solve it. If you found this breakdown helpful, please hit that like button and subscribe for more such bioprocess hacks. See you in the next video. Thank you so much for watching.